Hello and welcome to Design and Measurement with PMI. My name is Munir Jababli and I'm working as a software developer for the CAD and PMI options in Quindos. Quindos is an advanced metrology software and well known as the leading modular metrology software when it comes to complex geometry. And we as Quindos are part of the broad solution portfolio of Hexagon. But let's start with the presentation. Hexagon is the global leader in digital reality solutions that are empowering an autonomous and sustainable future by putting data to work. And if you think about our PMIs, they're also just data. And the most important thing to get the most out of your data is to break down the silos. Especially for the PMI, it's important to break down the silos between the design, the production, and the metrology. But mind the gap between the data creation and the data usage. And to help you to overcome this gap, I will show you today my experience on PMI metrologic implementation situations. Let me start with a general overview about the current situation and who is affecting our PMIs. First, we have the extensively reworked ISO GPS standards. A lot of new symbols and modifiers have been introduced. But even if they're not fully established in daily use, I will show you today that they are mandatory for PMIs and make our life much easier. Next, we have the CAD systems and designers. Here I see a large deficit in the implementation of the latest ISO standards, as well as they are often still based on the 2D representation when they are using PMIs. Then, between the CAD software and, for example, our software, we have the exchange formats and the native file converters. Here, it is also quite important to implement all the PMIs and the modifiers, and especially transporting the surface relationships is key. Then, at the end, is our CMM software and the metrologist. We have to interpret the PMIs as well, according to the ISO standard, and the AEs, or the metrologist, has to get familiar with the new workflow regarding the PMIs. Now I want to point out the difference between human and machine-readable PMIs. When we're talking about PMIs, there's one requirement that must be met. Namely, the PMI has to be machine-readable, or we call it a semantic PMI. So the difference is fairly clear. The PMI, or the feature control frame, is not like here on the left, just an arrangement of lines and curves that it just look like a 5. It has to be made out of symbols and modifiers and machine-readable numbers and symbols to get interpreted. And also, this also includes information such as unambiguous surface relationships and information that clearly describes our measurement task. So now I want to show you some typical issues when it comes to PMI implementation. Here we have on the left-hand side a PMI, and you can see on the orange color that it is attached to a line. This is inappropriate because we have to tell the machine that we have to measure the cylinder to evaluate the PMI, which is a runout. So it has to be like here on the right-hand side, that the PMI is attached to the cylinder, and so the machine can interpret this measurement task, knows to measure the cylinder, and evaluates the runout. Next, when it comes to multiple dimensioning, we also have to add multiple surfaces. Not like this example, where we have an 8 times 8.2 diameter, and the PMI is only associated with one cylinder. We have to make it like here on the right-hand side, where all the cylinders are attached to our PMI. Then life would be too easy if we attach all the surfaces to our PMIs and everything will be fine. In this example, we are ambiguous all for the existing surface binding. For example, like here, the 6 times 120 degree is attached to all the 6 surfaces of this body. So, but now we are missing a semantic information of which 2 surfaces belong together to form the angle. So in cases like this, we have to make our specifications separately. And let's talk now about 2D and 3D drawings. As I mentioned before, the GPS standard has been extensively reworked in the last years, including also plane and feature indicators. In the 2D world, a lot of orientations are transported by the view of the drawing. in 3D, we are missing these orientations. So we have to transport it by special symbols and modifiers. And the plane and feature indicator presented in ISO 1101 are helping with the implementation of the explicit dimensioning in 3D models. Let's have an example for this. So here you see a cube and a straightness on top of the cube. Then we have another, the same cube again, but now the straightness is attached to the long side of this cube. This means, like you can see here in red, we have to measure the lines here along the short side of the cube and on the other side along the long side of the cube. But in 3D, we are missing these informations. So here, the same cube again, and here in red, we see the expected nominal points. And to transport this information, we can use now the intersection plane indicators. And as you can see here on the left, we have the intersection plane, and it's parallel to datum A. And on the right-hand side, to get the nominal points like this, we have to make it perpendicular to the reference datum A. Then associated geometry elements and the modifier A. This is a typical example, again, a straightness attached, but this time to a dimensional line. This means we have to evaluate the straightness on the axis or the associated geometry element of this cylinder. But the problem is now that these dimensional lines are just non-semantic informations. So we have to transport this information by a modifier that is semantic. And therefore, we have the A modifier. Here you can see the circled A is the modifier for associated geometry elements, and then the machine knows it has to make the evaluation on the central line or the axis of this cylinder. And with adding or leaving this modifier, the measurement task is clear. So this is machine readable. Okay, theoretical exact dimensions, also called TEDs or TEDs. In ISO 1101 and 16792, we have some interesting notes. Like you can see here, the implementation of these TEDs is implicitly defined in the CAD model. Let's see on a specific example what could this mean. First, with 2D drawings. Here's a 2D drawing of a shaft. On the top of the plane of the shaft, we have attached a profile tolerance with the datum system A. The datum system A is the parallel plane on the other side. Then we have additionally these TED. The TED is fixing the height of these two planes, so this means the evaluation is the same like a position. Now, what happens if we are leaving the TED? Same example again without the TED. And now it's the same like you would use this modifier, which says direction only of A. And this means again that we have a parallelism. So you can see with just leaving the TED, our evaluation will change. But what happens now in the 3D world with PMI? Now, the TEDs are implicit, always present in the CAD model. So one beneficial thing, you don't have to add it anymore. But be careful, now without the TED, the position is called here in this example. And if you don't want to have the position, you have now to make it explicit by using the only direction modifier. And this would look like this. So to cancel this TED, you have to use it for the datum system, and this becomes a parallelism. So here are some recommendations from my side. First, avoid using profile tolerances on regular geometry. Especially for the metrologists, it's often hard to interpret this correctly, and even if you are experienced in ISO, this can be a struggle. Furthermore, be careful because the TED is always present in the CAD model, and this changes from the 2D world. So be careful if you are transforming your 2D drawings to the 3D world, and keep it in mind that your specification may change. Okay, a lot of talking about GD&T. Now another example about balloon numbers. A lot of our customers are using these balloon numbers as a specific, as a statistical indicator. So in this case, we have a balloon number 2 attached to the PMI. But it's not really attached because we are missing right now the semantic information between the number 2 and our PMI, which is the parallelism. A lot of ballooning tools out there are using name extensions to overcome this missing data gap. They're using, like here, a P005 to transport the balloon number 5 for straightness, or here the CR19 for horizontal dimension. our thought, this is pretty easy to parse and to process. That's not really a model-based definition way of working. So we have experimented already some things with our customers, and one thing was quite good, to use these attributes directly inside the CAD model. For example, the ID of the PMI to transport the information of the balloon number. Okay, a lot of talking about issues and problems that we have with PMI. But if you're asking me, today the display and use of the CAD model is state-of-the-art in metrology software. And I think tomorrow tools for reviewing, editing, and enriching our PMIs and the CAD models will become an essential part in the MBD workflow to enable the most flexible and solution-oriented way of working. And how this can look like, I will show you now in the next slides. So here we have the PMI healing. In our tools, we have a validity check, and that's the example from the beginning, where you can see that the PMI is arranged with the line of the cylinder. So the PMI is highlighted red in our list, and now you can delete the inappropriate surface binding and attach a new one to the PMI. So you can use it in the following up processes to generate your measurement program. Next, we are talking about enriching the CAD models. You can use the Quindos engine to define your own PMIs. You just have to select the surface and then choose one of the PMIs in the ribbons. Then you can also specify and use some more modifiers. This tool can also help if you are missing some modifiers or some PMIs inside your CAD system. Here you have the chance to specify some additional PMIs on your own and enrich your CAD models, and then afterwards you can use the workflow to process these PMIs. Then a lot of customers are asking about legacy data, and they're using still 2D drawings. They have no time, especially the design departments, to rework all their CAD models and attach PMIs now for the metrologist. Here we can use optical character recognition to parse your 2D drawing, provide all the PMIs as a list, and then you can add the PMIs to a list by your own directly on the machine. Afterwards, it's the same process. You can use these PMIs to generate your measurement program. Next, or another example for the legacy data, are the statistical export files. There are some DFD or DFQ files everywhere, and you can use these files to generate your own PMI like with the OCR. So sometimes you can export DFD files directly from your CAD system, or you have already DFQ files from older measurement programs. You will provide these informations again as a list of PMIs, and then you can arrange them with a surface. Last not least is the main important thing is one standard workflow. So you can use the PMIs that are already inside the CAD model or after enriching your CAD model with additional PMIs. You can review all these PMIs in the list, and the metrologist decides which PMI should be measured. You also have the tools of reviewing and checking for invalid PMIs. Then there's an organization of optimizing and optimizing the automatically selected probes. You can also change the measurement order and the used methods to measure this element. At the end, you will have a Quindos program for the measurement. And one important thing is that this program is not just a black box consisting of not readable G code. It's standard Quindos code, and advanced metrologists can easily read this code. Furthermore, the metrologist has also the chance to change the code, because when reality kicks in, sometimes it's needed to make some adjustments. And here you can also see our simulator for testing this measurement program, and that's also recommended to use. At the end, you will have the standard report files. So that's the presentation. And if you have any questions, please contact our partners in Benelux or CEO in Benelux, the digitalization and application department.